5 years ago, in October of 2014, I was in a meeting with a refiner who was very interested in Tier 3 gasoline. We were collaborating in a research project to address some weak links in Tier 3 technology. The project included pilot plant testing and commercial field testing on gasoline desulfurization. Now, 5 years later, I have been invited to talk today on this topic, Tier 3 gasoline, a wolf in sheep's clothing. And I thank Tom Closa for creating this title. It's a great title because my theme today is there is much more to Tier 3 than meets the eye. The Tier 3 gasoline standard mandates a 10 ppm average annual sulfur limit on gasoline in the United States. It was enacted in 2014 and phased in from 2017 to 2020. Until June of this year, most people thought it was a done deal. But in fact, a lot of work remains to meet the goal. During our 3-year research project, I was tracking the average sulfur in gasoline in the United States. Sulfur reduction toward 10 ppm has been slow. Starting from 31 ppm in 2011, the annual average sulfur crept down to 21 in 2017 and 18, meaning there's an 11 ppm gap still to be filled. And those 11 ppm are in the red zone, meaning they're much harder to get than those we got so far. Is the industry ready? What's the problem? And what's going to happen? Is the industry ready? I say no. But this is a minority opinion. In fact, for a long time, the industry consensus has been that Tier 3 is a done deal. And in second quarter earnings conference calls in August 2019, top refining executives were asked about it and they said yes. Their understanding is that their refineries and the industry are ready. There are several reasons why I disagree. To explain one of those reasons, we must focus on a specific part of a U.S. refinery. The fluid catalytic cracking process train is highlighted here in green. Starting at the left, the first green block is the feed hydrotreater, which pre-treats low-value, high-sulfur heavy oil. Then the second green block, the fluid cat cracker, cracks it to gasoline, which is then desulfurized in the third green block, the gasoline desulfurizer. The product, called FCC gasoline, is the largest component of the U.S. gasoline pool. It is also the source of almost all the sulfur in the pool. The key to meeting the Tier 3 spec is to reduce the sulfur in this FCC gasoline stream, and the weak link is in this train. This train, shown in yellow, has no gasoline desulfurizer. I will refer to this as a yellow refinery. And this FCC train has no feed hydrotreater. I call this a red refinery. So consider 3 categories of FCC refineries: green with a complete train, yellow with no gasoline desulfurizer, and red with no feed hydrotreater. The point is that green refineries have a huge advantage for making Tier 3 gasoline. In fact, wherever in the world 10 ppm sulfur gasoline is made today, like Europe and California, refineries fall mostly in the green category. The United States will now be relying heavily on yellow and red refineries. They will have little margin for error. Red refineries especially have a big disadvantage. They lack the FCC feed hydrotreater, which is a high horsepower unit that removes a lot of difficult sulfur from the heavy feed before it is cracked. Without the feed hydrotreater, the red refinery is placing the total Tier 3 load on the gasoline desulfurizer, which is a very low horsepower unit. What is the mix of green, yellow, and red refineries in the United States? This is one of many questions that were addressed by several industry groups during development of the Tier 3 standard going back to 2011. In 2011, MathPro did a study on Tier 3 refining economics using their LP model of the U.S. refining system. By MathPro's count, in 2011, we were 41% green, 24% yellow, and 35% red. In 2013, EPA's study reported the same distribution. The distribution is 40-20-40. Recognizing the weaknesses of yellow and red refineries for gasoline desulfurization, these Tier 3 studies looked at every U.S. refinery and estimated what would be required to move it up to a level for making Tier 3 gasoline. The study said the U.S. needed 82 capital investment projects, consisting of 16 new builds and 66 revamps of feed pretreaters or gasoline desulfurizers, to move red and yellow refineries toward the green category. A 6-year phase-in was allowed by EPA for these investments to occur. It added up to $3 billion in capital investment. Now, everything I have shown you so far was known and publicly available 5 years ago in October 2014 when I was meeting with that refiner planning our Tier 3 research project. And it was accepted by the industry back then. That fact is well documented in our reports. How much of this capital investment actually occurred? The answer to that question has been known to my client group for 2 years, but is otherwise breaking news today. The answer is nothing has changed. By my count today, we are still 40% green, 20% yellow, and 40% red. During the 6-year phase-in for Tier 3, there were only a handful of capital investments targeted at what is clearly the weak link, which is to get sulfur out of the FCC gasoline. After 6 years of capital investment, there has been no net progress in upgrading our FCC process trains for Tier 3 gasoline. This is one reason I disagree with the strong industry consensus that the industry is ready. Now, this green, yellow, red analysis is a good argument that should not be dismissed because yellow and red refineries face serious challenges making 10 ppm gasoline. I am going to come back to this green, yellow, red analysis in a moment, but let's move to the next question. Given that these investments did not occur, what's the problem? In a word, octane. The FCC train is the main machine for producing octane barrels. And when you desulfurize FCC gasoline, you destroy some of those octane barrels. And the redder your refinery, the more octane you will destroy. Thanks a lot for your attention. Tier 3 gasoline, a wolf in sheep's clothing, is taken from a 3-year multi-client research project that was completed in 2017. This is part 1 of a presentation made at the OPIS Fuels and Octane Forum, October 24, 2019. Parts 2 and 3 of the presentation will be posted publicly in coming weeks. We hope all U.S. refiners will choose to buy the reports on our 3-year research project, which are available immediately to anyone.